Yes, I will come to the Earth expansion.
Yeah.
It's of course outrageous idea, but
It
I
is.
was first want to explain a little bit about the ice age graph on the top left, because you see a clear pattern as well. It goes very steep up to a point, and then slowly goes down, steep up,
Yes, it does.
down, and so on. This is also a pattern. And
What does it show? What does that graph show?
It shows the say the upward flank.
Yeah.
Shows the recuperation of the biosphere
Uh-huh.
after a crustal deformation.
Mm-hmm.
So the crustal deformation is the downward flank, and the upward flank. Then upward flank is the, let's say, recuperation of the whole biosphere, changing to adapting to a changed climate.
I see.
Yeah. Of course, this is a enormous catastrophic for the Earth and everything that lives on it.
Yes, I have questions about that.
Yeah. There is to come to expansion, I have to explain a little bit more about the probability that these two patterns match onto each other, because the graph on the top left comes from the South Pole.
And the South Pole, now this is interesting, the South Pole has not moved.
Has not moved. And it's also the conclusion, because if the North Pole moved so much, and the South Pole moved as well, you will never find this matching pattern. So my conclusion is that this proves that the South Pole did not move, or hardly move. And that is, of course, directly comes to your conclusion. Okay, how is this possible? It only can be expansion. What else can it be?
Yeah, what else can it be? It can be, well, since it's a sphere, the Earth is a sphere, it has to be some kind of deformation.
Yeah, and there are, of course, there are expansionists who explain the Earth expansion from looking from isochrons. I can, of course, pull this up as well. I'm back again. This isochronic map of the ocean floor. And isochron means iso is the same, and chron is time. Yeah. So these red areas are of the same time, and the green areas are also of the same time, and so on.
Yeah.
And this should be the proof that Pangea had existed, and so Africa joined to South America, and India was against Africa, and Australia was against Antarctica, and so this Pangea. I guess most of your listeners know this Pangea idea.
Yeah, and I've always wondered why. I mean, why did suddenly all the continents started to move around on Earth? It never made sense to me. But this theory actually makes it make sense.
No, there's no mechanism as well. And there were even, they call Pangea the supercontinent. There were even 6 supercontinents before Pangea.
Yeah.
This is a geological idea. But of course, this is difficult to prove. But what is, let's talk about expansion. There are a lot of expansionists who say this proves expansion. So that, for example, Australia and Zealandia, that is east of Australia, was against South America. And so you can all put this on one globe, but a smaller globe.
Yeah, it's going to be a much smaller globe.
Yeah, much smaller globe. about 65% of the current diameter. So it's not very small, but of course volume goes to the power of 3.
About the size of Mars, perhaps, or Venus, maybe? Venus?
Yeah, something
Venus
like
is
that.
bigger than Mars.
Yeah, I don't know exactly, but I didn't looked into this. But I had some debates with expansionists about their ideas, because there is a problem with their theory of expansion, of timing the expansion. This isochronic map is made with a constant diameter in mind. So geologists made this with a constant diameter in mind. This is important to understand.
Yeah.
Because when you want to time an expanding Earth with this model, you cannot use this time bar on the bottom of the map.
No.
And why not? Because you're comparing apples with pears. So you have to, what you can do is you can say, okay, what I can say for sure is red belongs to red. It's from the same era, the same magnetic orientation. And green belongs to green, to keep it simple.
Yeah.
And
and what you can see, I mean, as a layman like myself, is that large chunks of the sea floor, which I mean, the parts of the sea floor that seem to be in between continents, is younger than other parts of the Earth. For instance, the landmass, and also the parts of the oceans that are closest to the continents, which would indicate that, well, there might have been some kind of expansion, and these red areas didn't even exist from the beginning. It wasn't there. It just, and when it expanded, it kind of appeared. It just appeared. So I guess geologically, you can see that the middle part of the Atlantic, for instance, is what is it now, 10 million years old or something, and if you look on,
let's say officially not older than 40 million years old. So the oldest part, the Earth is 4.5 billion years old.
Yeah.
This can be proven by taking rock samples and so on. And I believe uranium dating. But the oldest part of the seafloor is officially not older than 180 million, maybe 200 million years old.
Yeah. And how do these experts, these scientists who are not expansionists, how do they explain that?
They explain it with the reorientation of the magnetic particles on the seafloor. So this is this so-called how do you say this? Umpoling, changing of the poles, changing of the magnetic poles.
The magnetic poles.
Yeah. And there is no, let's say, other dating of the seafloor than this changing of magnetic pole. There are a lot of problems when you look deeply into this paleomagnetic science with the dating of the seafloor, and there's a lot of controversy about the timing and the exact position of poles.
Let's say, if I just want to make it simple here now, if you have a balloon, let's say you want to inflate the balloon, and you inflate it from, let's say, well, from there is a hole that you're supposed to inflate it from, and you blow your air inside into that, and that should be then, in this analogy, the South Pole, because the South Pole stays where it is.
Yeah.
And then the Earth, aka the balloon here, expands, and if you have a pattern written on the surface of the balloon, it will move away from each other. It will, I mean, it will steer away from each other, and it will look differently, and there will be new, quote unquote, new areas created, because it's I mean, the tissue, the fabric of the balloon will stretch but it will do that uniformly. But in your theory, as far as I understand, I mean, because in this analogy, in this example, the so to speak, north pole of the balloon would stay in the same place, wouldn't it? It wouldn't move. It would be the same.
South Pole. The South Pole.
Yeah, but even the North Pole, actually, in the balloon example, if you inflate it uniformly.
Ah, yes, exactly.
So I mean, it's kind of like in your example here, the Earth isn't actually a proper balloon. It's been skewed in a way. It's been, I mean, the Earth has expanded more on one side than on the on the other. And why is that?
Yes, you said it very well. You can see on this map that in the Pacific, on the left of the map, this red area is much bigger than the other red areas. So
Yeah, I
this
can see that. Yeah.
If the expansion theory is correct, then the red and green areas expanded much more, and so this expansion was not uniformly. And this expansion could explain not on a flat map, but when you project this on a sphere, you can see that from its expansion model, Greenland was pushed over the North Pole.
Yeah.
And I can take you to another picture. That is this one.
Oh yeah, that one's cool. Yeah, you can see yeah. There's a ring around Antarctica.
Yes, this exactly confirms that Antarctica stays on its place, because you see this expansion ring fully around Antarctica, and this green and red and a little bit yellow.
Yeah.
So when expansion is correct, it was somehow moved and pushed from the South Pole.
Okay.
And then the other is expansion, and most expansionists cling on to this idea that somehow the Earth gained mass over time and grew from the inside.
And that's the question. I mean, from where does this material come? How can it grow from the inside? That's a very difficult one to understand for a layman.
Yeah. The most likely explanation is from the sun, coronal mass ejections from the sun that are caught in the magnetosphere. So the magnetosphere is pretty much larger than the Earth itself, about 4 to 5 times larger. So when a coronal mass ejection, several types of flares, coronal mass ejections, they have several classes of largeliness.
Yeah.
The X flare is the largest one, and they also, like in earthquakes, they classify them in 1, 2, X1, X2, up to X10. But then, of course, there are, like in earthquakes, there are X flares that fall off the scale. But when such a large coronal mass ejection could hits the Earth, the magnetosphere catches all these subatomic particles. And these subatomic particles are guided through the magnetosphere to the flux lines, slowly into the core of the Earth, and then transformed into mass.
Yeah, so but on its transportation, on its way down into the core of the Earth, it's never manifested as matter. Then,
not yet.
No, it's only when it arrives.
Yeah, subatomic particles are not, let's say, atomic particles.
No,
they can more easily travel into the Earth than. Of course, it is fringe science.
Yeah,
you have to.
it's very far out, so to speak.
It's very far out,
but it's very interesting. I mean, what do we know? We don't know anything. We don't have any clue about what happened.
We have no clue.
Planet. We have no clue. So why not? I mean, yeah.
Why not? But I tend to bend more towards decompression, because decompression explains it so well. And I will also explain why. Because these X flares caught into the net of the magnetosphere and are guided into the core of the Earth. It's a little bit artificially constructed. I want to have a theory for my expansion. But decompression, I think, wow, because the atmosphere could be blown away by a large X-flare, bit by bit. And this could explain, let's say that the atmosphere became less dense over time.
I just quit that, yeah.
Thank you. So that the atmosphere became less dense over time through these X-flares that hit the Earth. So the Earth atmosphere loses mass.
If you like this video and other interviews and talks and stories on Mind the Shift, please like, share, and subscribe. And most importantly, become a patron. Click on the Patreon link in the description box if you're on the cell phone, or in the banner if you're on a computer. I appreciate all the support. It allows me to make more and better content. Thank you.